Hello everyone, welcome to another video tutorial. For today's lesson, we are going to discuss quadratic functions. So we have here our most essential learning competencies. First, model real-life situations using quadratic functions. Second, represent a quadratic function using the following. We have the table of values, graph, and an equation. Third, transform the quadratic function defined by y equals ax squared plus bx plus c into the form y equals a times the quantity of x minus h quantity squared plus k. Before our MELCs, let us define first what is a quadratic function. A function of degree 2 described by the equation in its standard form f of x equals ax squared plus bx plus c, wherein f of x can be changed into y. We also have y equals ax squared plus bx plus c as the standard form of quadratic function, wherein a should not be equal to 0 because when we have a as 0 and 0 times x squared, that will be equal to 0. And when our quadratic term is absent, therefore, it will not be a quadratic function anymore. So we also have a, b, and c as our real numbers or the numerical coefficients. So now, let us proceed with our first target, which is to model real-life situations using quadratic functions. And for us to do that, let us help Mr. Rivera. So the problem goes like this. Mr. Rivera is renovating his house. Before the lockdown, he managed to buy square tiles with 5 sizes. He wants to determine the area of each tiles. Let us help him. So if we analyze the problem, this will be its illustration. So here are the 5 square tiles with 5 different sizes. One is 2 by 2, the other one is 4 by 4, the third one is 6 by 6, and then we have 8 by 8, and the biggest one we have 10 by 10. For us to find the area of the squares, we have to use our formula. The formula is a equals s squared. This is true to all the area of the squares. So let us find out all the areas. So we represent the sides as s, and then we represent the area as capital or big letter A. Write down the sizes 2, 4, 6, 8, and 10, and for the areas, we will have to square each of the sides. So for the first tile, 2 times 2 or 2 squared, that is 4. Second tile, 4 squared, 16. Third tile, 6 times 6 or 6 squared, that is 36. Fourth tile, 8 squared is 64, and then the fifth tile, 10 squared is 100. As you can see, these are the variables s and a, can be denoted as the variables x and y. So these are the values or the areas of the tiles. So we have helped Mr. Rivera to find out what are the areas of the tiles through modeling quadratic function in real life. So we have already achieved our first MELC. Let's proceed with our next. So the next one is to represent a quadratic function using the following. So table of values, graph, and an equation. Let's proceed with the table of values. So a little trivia about table of values. It is a graphical representation in tabular form of the data or information. So for the first example of table of values, let us have s as the first variable and a as our depending variable. So it is somehow the same on our previous table regarding Mr. Rivera's situation. So we have here the sides, so 3, 6, 9, 12, 15, so that is S, and then we have A, which is 9, 36, 81, 144, and 225. So as you can see, we can establish a pattern using this table of values so that we can know that it represents a quadratic function. So this is the pattern. When we subtract from right to left, we will have the same differences in S, or the values of X. Let us check. 15 minus 12, it's 3. 12 minus 9, 3. 9 minus 6, 3 also. And 6 minus 3, 3. So the first differences in S will be the same. For the differences on A, or the depending variable, or these are the values of Y, so as you can see on the first try, on the first differences, we have here different numbers. But when we try it again on the second differences, we have here the same differences or same numbers. So 225 minus 44, 81, 144 minus 81, that's 63, 81 minus 36, that's 45, 36 minus 9, it's 27, and then when we subtract 81 minus 63, it's 18, 63 minus 45, it's also 18, 45 minus 27, also 18. So as you can see on the second differences, we have 18. So we can say that if the first differences in X are the same, and then the second differences in Y are the same, therefore this represents a quadratic function. Let's proceed with the next example. So we have here the values of X, negative 2, negative 1, 0, 1, 2, 3, and 4. And then the values of Y are negative 5, 0, 3, 4, 3, 0, and negative 5. Let us subtract to find the first differences in X. 4 minus 3, 1. 3 minus 2, also 1. 2 minus 1, 1. 1 minus 0, that's 1. 0 minus negative 1, positive 1. Negative 1 minus negative 2, also 1. So the first differences are okay, or they are the same. So in cases wherein we have different number or different answer, different difference on this, therefore this will not be considered as a quadratic function anymore. But since they are the same, so we can still check on the second differences in Y. Negative 5 minus 0, that's negative 5. 0 minus 3, that's negative 3. 3 minus 4, that's negative 1. 4 minus 3, 1. 3 minus 0, 3. 0 minus negative 5, positive 5. So it is normal that on the first differences on Y, we have different answers. But as you can see, we have certain patterns. So let's find the second differences. Negative 5 minus negative 3, we have negative 2. Negative 3 minus negative 1, negative 2 also. Negative 1 minus 1, negative 2. 1 minus 3, negative 2, as well as 3 minus 5, negative 2. So on the second differences, you can see that we got negative 2. So they are the same. So again, when the first differences in X are the same and it produces equal or same differences in Y, therefore this represents a quadratic function. So in summary or in summarizations, since the differences in X are equal and it produces equal second differences in Y, therefore the given table of values represents a quadratic function. So now that we are done with the representations of quadratic functions using table of values, let us now proceed with the graphs. So a little trivia, if you toss a ball to a friend, the path of the ball will be a curved line. So this represents a real-life situation or application of quadratic function. Therefore, the graph of a quadratic function is like a ball tossed to a friend or a curved line. So this curved line that is a U-shape is called a parabola. So the graph of a quadratic function is called a parabola. So here are some examples of the graphs of quadratic function. So this is a U-shape opening upward. And then the other one opens downward. So I'm just showing you on what a quadratic function looks like, or the graph of quadratic function looks like. Not necessarily that we have to graph this, because our MELC says that we have to represent only the quadratic function as a graph. So graphing will be on our next topic. So So now that we are done with the representations using the graph, let us now proceed with the equations. So what are the equations that will qualify as a quadratic function? So these are the examples. So for the first example, under quadratic function, we have here f of x. So we have here f of x, that's for quadratic function. And then look for the quadratic term, we have here 4x squared. Therefore, even though it is not arranged in its standard form, this is considered as a quadratic function. Next, for y equals 2x times the quantity of negative x plus 2, so we have here y as the variable for f of x. And then as you can see, there is no quadratic term. But we can still simplify 2x and the binomial, which is negative x plus 2. Simplifying the second example, this will lead us to y equals 2x will be distributed to negative x. It will become negative 2x squared. And then 2x will also be distributed to 2. So that is plus 4x. So as you can see, we now have our quadratic term after simplifying. Therefore, this is also a quadratic function. For the last one, we have here a equals b squared minus 5b. So we use two different variables, just like the situation with Mr. Rivera, wherein we used s and a as our variables. So we have here a, and then we have here the quadratic term, which is b squared. Therefore, this is also a quadratic function. So for those equations that are not quadratic, that is the first one, when it is linear, since we have 3x, and we have 1 as the highest degree of this equation. So it is a linear equation or linear function, not a quadratic one. And then for our next example, although we have here f of x, but we have here a linear term in its absolute value. So this is not a quadratic function. And then on the third one, although we have here y and then b, the highest exponent or the degree will be 3. So this is a cubic function, not a quadratic function. So those are the examples of the equations that will satisfy or will qualify as a quadratic function. So now we are done with our second MELC or target. For our last target or last most essential learning competency, we have transforming quadratic functions defined by, so this is the general form, y equals ax squared plus bx plus c, or the standard form. And then we have here y equals times the plus k as our vertex form. So as you can see, when we transform from general to vertex form, we have here the formulas for h and k. So the formula for h will be negative b over 2a, and then the formula for k will be 4ac minus b squared all over 4a. Proceeding with our first example, so transforming the general form x squared minus 2x minus 4 into its vertex form, identify first the values of a, b, and c. So a equals 1, b equals negative 2, and c equals negative 4. So now let us substitute it in our formula. So h equals, so negative is already in its formula, and then write the value of b in a parenthesis, so that is negative 2, all over 2 times the value of a is 1. Simplify. Negative 2 times negative symbol, so it is understood as negative 1 times negative 2, that will become positive 2. And then for the denominator, 2 times 1, that's 2. And 2 divided by 2, that is 1. So we have here the value of h, which is 1. Next, for the value of k, let us substitute 4 times 1 times negative 4 minus negative 2 quantity squared all over 4 times the value of a, which is 1. Simplify. 4 times 1, it's 4 times negative 4, negative 16, minus negative 2 squared, that is 4. All over 4 times 1, that is 4. Negative 16 minus 4, it's negative 20 over 4. Negative 20 over 4, that is equal to negative 5. Therefore, the value of k is negative 5. K equals negative 5. So for the shortcut, you can still find k using h, using our original quadratic function. So let's say we have f of x equals x squared minus 2x minus 4. Use the value of h as x. So this will be 1 squared minus 2 times 1 minus 4. 1 squared is 1, negative 2 times 1 is negative 2, and then copy minus 4. 1 minus 2, that's negative 1 minus 4. We will also get, or we can also have negative 5. So they are the same. So that is the shortcut on how you have to find the value of k without using its long formula. So for the transforming, let's use this pattern. F of x equals, so the value of a is 1, so you can write 1 and then copy x and then minus, and then the value of h is 1, and then copy the closed quantity and then squared, and then copy plus, and then the value of k is negative 5. As you can see, we can still simplify this equation since we have here 1 and then we have here 2 operations. So this will be f of x, and then since any number multiplied by 1 will be the number of itself, you can not write 1, or you can omit 1. So this will become the quantity of x minus 1 quantity squared, and then positive times negative, it's negative, so minus 5. So this is our final answer. So now let us proceed with our next lesson on vertex to general form. So a while ago we have general to vertex form, and on this part we have here it's vice versa, which is from vertex to general form. So let's say that the given is the hk, and then we have to find ax squared plus bx plus c. So this is the step. You have to expand the equation applying special products. So let's have our example. So let's say we have y equals 3 times the quantity of x minus 2 quantity squared plus 4. It will be transformed into its general form. So simply let us rewrite y equals 3 times x minus 2 quantity squared plus 4. So following our rules for performing the operations, so that's GEMDAS or PEMDAS. GEMDAS stands for groupings, exponents, multiplication, division, and addition, subtraction. So let us first perform the numbers inside the parentheses with an exponent. So as you can see, x minus 2 quantity squared is a square of binomial under special products. So just a review on how to square a binomial. So the square of binomial will lead us to an answer of a perfect square trinomial. So let us just copy first y equals 3, and then we all know that when we solve this square of binomial, we will have a perfect square trinomial. So we have 3 terms, and then copy plus 4. So for us to find those 3 terms, for the first term, we have to square the first term. So this is for 1. And then for our second term, on the trinomial, that would be twice the product of the first and second term. And then for our third term of the trinomial, that will be the square of the second term. Now let us perform squaring of binomial. So first term is x. So as you can see, we have to square the first term. So that is x and then squared x squared. So for our second term of the trinomial, we have to get twice the product of the first and second term, meaning we have to multiply the first term x and the second term negative 2. After multiplying, this will be negative 2x. But still, we have here twice the product, so we have to multiply it again by 2. 2 times negative 2x, that is negative 4x. So the middle term will be negative 4x or minus 4x. After that, we square the second term for our third term on our trinomial. That's negative 2 squared, and negative 2 squared is positive 4. After that, as you can see, these operations with 3 and the trinomial will be multiplication. So we have to distribute 3 to x squared, 3 to negative 4x, and 3 to positive 4. Let us multiply. 3 times x squared is 3x squared. 3 times negative 4x is negative 12x, and 3 times 4 is positive 12. Do not forget to copy plus 4. Now, let us combine like terms. So, the like terms here are 12 and 4 only. So, just copy 3x squared minus 12x, and then add 12 and 4, that will be positive 16. So, we have here our general form y equals 3x squared minus 12x plus 16, since it has the same format with the general form on our problem. So that will be on quadratic equations, solving quadratic equations. So we have modeled quadratic equations in real life. We have represented it using table of values, graphs, and equations. And now we have transformed it from the vertex form to the general form and general form to the vertex form.